we are going to be doing a little activity here where we look at the amount of precipitate in some graduated cylinders. And so I first want to talk about the reaction that we have. And so the reaction that we're going to be looking at is copper to nitrate and sodium phosphate. Now, copper to nitrate is actually going to be like a turquoisey color. Okay, and so I'm going to go ahead and put this, it's going to be kind of turquoisey. We're going to see that our sodium phosphate is going to be colorless, and it's going to be a solution, AQ. This one's going to be a solution, or AQ. And this is going to react in what we call a double replacement. And so we're going to see that the cations switch spots. And so I'm going to end up with NaNO3 aqueous, and I'm going to end up with copper to phosphate. Remember that the 2 is going to be the charge on the copper, and so it crisscrosses. And what we're going to see here is that we have a solid being formed, and we have another colorless solution being formed. And our sodium compounds tend to be colorless. Copper compounds tend to be colorful, and in fact they're going to be more of a blue turquoisey precipitate, which we're going to see here in just a second. All right, so we have these right here that we're going to take a look at and then fill in and color in a little bit. And so so this is going to go along with our lab and our station learning. So this is our first station, and this is our first graduated cylinder right here. So take a look at the volume of our solid. We're going to, all right, so I'm looking here, and I'm estimating, but it's a little bit underneath like 8 or 9. And so I'm going to draw that in nice and solid. And so here we are, it's like right in here. Okay. And there's our solid. And then everything else we see is going to be colorless. And I see up above is colorless. I'm going to shade that in just a little bit with like some white, or I'll do a gray so you can kind of see it a little bit more. And we're going to see that this is colorless on top of that. And in fact, I may drop this guy down just a little bit more. Let me see if I can make it a little bit more fine-tuned here. So we're like in here a little bit. And then we've got our colorless solution on top there. Okay, and so for our volume, we have right here, this is going to be our copper to nitrate. So this is our CuNO3 2, and here it said that we use 10 milliliters. And then we had our sodium phosphate, which is our Na3PO4, and we had 90 milliliters there. Let's go ahead and move on to the second one. Draw that in our data table, okay? And then we want to take a look at what color the solution is right up above, and it's colorless. All right, so here is station 2. All right, so station 2, we have 25 milliliters and 75. So 25 and 75. And here's station 2. So you can take that volume and do approximate as well. So we've got just a little bit more here. So I'm going to make sure I go up just a little bit more, a little bit higher. Still not quite to the 10. And if I look, we are going to have colorless up above still. So this is going to still be colorless. Okay. So now we're going to keep on. So here's station 3. And we're going to start to notice that station 3 has a whole bunch of precipitate kind of just stuck right there. And here's the card. Okay, so here we're going to have 30 and 70. And we're going to have to fudge some things just a little bit. But we did have some precipitate stuck to the side. And this is going to be colorless above. Should be. It got stuck. Here's station 4. So here we have 35. And 55. And again, here's our information and our precipitate. And so that jumped up to almost 20. So let me zoom way in here. Maybe right about in there. Again, it doesn't have to be perfect on this. And it's still going to be colorless over the top. Station 5. So station 5 is where we had, I think, 50 and 40. Let me double check that. Oh, there's our volume. Station 5. It was 40 and 60. Okay. So let me go back here. So it was 40 and 60 milliliters. And it has a little bit less, like maybe 13. It's still over. Okay. And this one's kind of hard to tell, so I'm going to leave it blank on it, okay? Although it looks pretty clear. Pretty colorless, okay? And then let's take a look at the last two. Here's our volume. Here's station 6. A little bit over 6 milliliters of precipitate. There's station 6. There's station 7. All right, so let's go back. Station 6 was 55 and 35. 80 and 20 for station 7. And we know that here our precipitate went way down. Went back down to like 5. And we're going to notice that on And it may be hard to see, but on station 6, we're going to notice that it starts changing color up above. And we're going to see that there is this light blue color up above it. And then in number 7, a little bit over 6 milliliters of precipitate. There's station 6. There's station 7. And we have very little precipitate down there, like 5. All right, so those are the stations again. And we'll take a look. And so we said that we would have 5 down here. So just not very much at all in terms of our precipitate. And then we've got a lot right here. And it's going to be blue. And in fact, it kind of is a little bit of a darker blue. It was even harder to see. All right, so what we want to do now is we want to look at what was our excess and what was our limiting reagent. Okay, so again, our reagents are going to be our 2 compounds down here that we see. Again, these are our reagents, our reactants. And so what I'm going to do is I'm going to look at what I have in my beaker. And in my graduated flask or graduated cylinder, I have NaNO3 in all of them. Okay? So I have this clear and colorless. So I have NaNO3 is in all of these. The solid is going to be the Cu3PO4 solid in all of them. And so if I have anything extra, an excess reagent, the color is going to be able to tell me here. So if I look up here, in this one, I have no color, so it's colorless, which means that I have Na3PO4 in excess. So Na3PO4. And so I have no color, no color, no color. If I take a look down here on these last 2, I have this turquoisey color, which is going to tell me that I have excess copper reagent. And so here I'm going to see that I have CuNO3 2 in excess for these 2. And so I have a color to these, and so there's some copper to nitrate in there as well. So again, colorless is going to tell us that we have Na3PO4 extra, and then our CuNO3 2 is going to be our limiting reagent. And then here, where it switches color, Na3PO4 is going to be our excess reagent. Now, this point in here, that point where it changes, this is called our stoichiometric point. And it's going to be in there somehow. So I want you to describe what happens as we change the amount of reactant A. All right, on the back, we got some information here. And so we have 0.11, 0.16, 0.18, and then 0.18, 0.18, 0.18, and 0.18 for our reaction. We worked some problems out here, and these are our theoretical yields that we got. And again, this is what we should have gotten. So let's take a look at our data table. Again, our data table is always going to give us our X and then our Y. Another way to think about this, we changed up the volume, so that's our independent variable, and we measured or calculated, in this case, our dependent variable. So if I take a look here, I think on our Y-axis we can count by 0.2, so there'd be 0.2, 0.4, 0.6. I'm sorry, 0.02, 0.04, 0.06, 0.08, 0.10, there's 0.10. So there's 2, 4, 6, 8. There's 20 right there. And yeah, that should be fairly even. And then in terms of our values here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think we can do 2 as well. So I think we can do, there's 10, 20, 30, 40, 50, and 60 milliliters. So here we have our mass in grams, and here we have our volume in milliliters. So when I graph this, I'm going to have 10 milliliters and 11. So that should go right in there. I'm going to have 15 milliliters and 0.16. There's 0.14, 0.16. And then the rest of these, 20, is going to be at 18. Sorry. 18, 18, 18, 18, 18. And I put these in the wrong spot, didn't I? I sure did. Oh, no, I did it on this one. So we got 18. There we go. Okay. Now, with this, we should see that if we have no reactant, I'm going to have no product. And let me go ahead and draw in a couple best fit lines. So I've got a line right here. It's not the best, but we'll go with it. And we have a line right here. All right. So looking at this, we're going to notice this portion right here. Okay. And that, I really shouldn't have used that color. But this guy right here, where it meets, this is called the stoichiometric point. And so what we're going to do is we know that as we increase the amount, we're going to see that we increase the volume and then it stays constant. So if I were looking at this in terms of ACT, I would probably put an arrow going down here because we're increasing. I would see that we increase and then we hold constant right here. And so looking at this data, if I look right in here, I'm going to see that there's something going on here because it remains constant even though I'm changing the amount of reactant. And if I take a look, that corresponds to this area right there. And so we say that the reactant A here has lost control. So in this portion, A has no effect on the product. Okay, it's lost control, which means that this is going to be our excess reagent. Well, in this section of our graph right here, we're going to see that A has control of it, of the product. As we increase the amount of reactant, we can increase the amount of product. And so here, A is the limiting reagent. Okay, and so again, we've got this stoichiometric point here that tells us when we switch from one limiting reagent to another. It tells us the perfect amount of our product that we're going to see.